Today, coal is used mainly for electricity generation around the world and in the United States.
We need to focus on electricity because electricity is the main thing that we make with energy. 40% of our energy use is used to make electricity. And transportation is actually a significantly smaller portion of our energy use.
What technologies might help America and the world have enough electricity without CO2 emissions?
Wind energy is a very good resource where the wind blows a lot. The cost of wind energy in many places is now competitive for power generation with any other clean energy supply. It is domestic and secure, and the fuel costs are zero.
The most recent statistics indicate that wind provides 6% of the U.S. electricity supply and 4% of the world's electricity.
With technology and how it's evolved, we can get electricity just by putting photovoltaic panels on the roofs of people's homes. That requires a different kind of distribution grid, one that's able to take power as well as deliver it.
The most recent statistics indicate that solar provides about 1% of the electricity supply, both in the United States and globally.
The challenge with solar and with wind is they are intermittent. When the wind isn't blowing, when the sun is down, you don't have that power. And the intermittency can be quite dramatic. You can lose 80% of your solar in just a matter of minutes. It can come back in a matter of minutes too, but that creates challenges to the grid. That intermittency means that you have to back those energy systems up with other kinds of energy, often nuclear, gas, coal.
The way that our grid is set up is that we are forced to basically make almost exactly the same amount of electricity as we use at any given moment. You have to have an almost perfect balance between electric supply and electric demand, and if that gets out of whack by even fractions of a percent, you're going to get blackouts.
So for every kilowatt of intermittent power that we have on the grid, we need a backup system. You're doubling your capital costs because you have a backup system. That really is a big problem.
There's a lot of potential in solar and wind. We are, in fact, investing less worldwide in energy research, in developing more efficient, more powerful solar and wind technologies than we were in the 1980s. We're also behind in improving our transmission systems and our storage systems so that we can use those technologies as baseload power, as 24/7 sources of electricity, as we use coal today.
Electricity storage to me is the holy grail. If we had good storage systems, if we had battery systems that they're working on, it's really going to make a huge impact on our energy needs. But right now, the technologies are inadequate. Batteries are inadequate.
What it means is you have to start changing the way the grid works so that we can move towards that future where the intermittent sources aren't going to affect the grid in a negative way.
The good news is that it's a combination of new energy technologies and new information technologies, sophisticated enough to enable us to manage these new electricity flows that are opening up all sorts of possibilities for a smarter, cheaper, more reliable electric system, and one that's cleaner.
Infrastructure change on the scale that we're talking about is a slow process. And without the infrastructure change, we can't just shut off the fossil fuels and expect to have all of the services from electricity that we rely on right now, because we just don't have the tools to do that.
Right now, only a third of our domestic energy comes from carbon-free energy sources. But most of that is nuclear energy. The rest, nearly 2/3, comes from fossil fuels, mostly coal and natural gas.
In the meantime, the climate problem, the emissions problem is serious enough that we need to deploy these clean coal technologies that we already have, and we need to start putting them on commercial scale coal plants and using them to keep carbon out of the atmosphere, because we're not there yet with renewables.